All right, let's take a look at a few problems in section 1.7. We're going to start with number 45. And we want to use interval notation to express this solution set and graph the solution set on a number line. So in this particular problem, we've got an inequality that involves fractions. So the first thing we want to do is clear the fractions. We want to multiply by the smallest number that 6, 9, and 18 divide into evenly. This number would also be called the least common denominator. And it turns out 18 is the smallest number that 6 divides into evenly, that 9 also divides into evenly, that 18 also divides into evenly. So we're going to take that number and multiply each term by that number, and that will clear the fractions out of the problem. So we're going to multiply every term by 18. And so what happens is each denominator is going to divide evenly into this 18. So 6 divides evenly into 18, giving us 3. 18 divided by 6 is 3. In this second situation, 18 divided by 9 is 2. And in the last situation, 18 divided by 18 is 1. So remember, our whole point in doing this is to clear the fractions. So I'm now left in first position with 3 times x minus 18, and that's greater than 2 times the quantity x minus 9 plus 1 times 1, which is simply 1. So notice how we were able to completely rid the problem of fractions, at least for the moment. They may come back at the very end, but we don't have to work with fractions right now. So let's distribute. 3 times x is 3x. 3 times negative 18 is negative 54. That's greater than or equal to 2x minus 18 plus 1. And so we're able to combine like terms on this right side. And that gives us 2x minus 17. Negative 18 plus 1 is negative 17. And now I'm going to subtract a 2x from both sides of the equation. And so that leaves me with x minus 54 greater than or equal to negative 17. And what I'm going to do with this is, in order to get x on the right side of the equation and constants on the x on the left side of the equation, constants on the right side of the equation, I'm going to add 54 to both sides. And I get 37. On the right, x on the left, and I see that x is bigger than or equal to 37. So the problem that I was working told me to use interval notation to express the solution set and to graph the solution set on a number line. So those are the two things I want to do. I want to write x greater than or equal to 37 as an interval. So greater than or equal to 37 means my x can be 37 or anything to the right of 37. So as an interval, that begins with a bracket on the left, 37, and this part of the interval notation means x can equal 37. And when I put comma and infinity, that means x can be anything to the right of 37. I can move indefinitely to the right. So this is my solution set in interval notation. And then to draw my number line graph, I draw a double-ended arrow. That's my number line. And then I'm going to put a solid circle above 37 because 37 is part of my solution. And then I show an arrow extending to the right because I can include, or I do include, all numbers bigger than 37. All right, and that would be my number line. If I don't have to show a lot of numbers. I do need to show the 37. If I show anything else, here I chose to show 0. It just needs to be in the correct position relative to my 37. So numbers need, if anything I show on the number line needs to be appropriately related in its position to anything else on the number line. All right, so those would be the two things. Typically, if you were working this in my math lab, you'd be entering this interval and you would be selecting the correct, you would have a choice of graphs and you would be selecting the correct one. So this is an example of what you would find in your My Math Lab homework in an exercise that looks like number 45, exercise 45 in section 1.7.